Okay, welcome everybody to session 4 of the Associate Cloud Engineer Certification Workshops. So we are now in the second half of Module 2. So basically we are here. So again, hopefully you've completed a lot of the Module 1 self-study and also making inroads on the Module 2 self-study. So that we'll go straight into it. And again, if you're following along in the PDFs, this is in your Module 2 and it's slide 63. So we're going to talk about cloud load balancing, right? Now, we have different types of load balancers in Google Cloud. And so whenever we're setting up a load balancer, there's 3 kind of main parameters that we have to think about. First of all, we have to think about what protocol is being load balanced. Now, the most common protocol is HTTP or HTTPS, but we do have other load balancers as well, UDP, TCP, and SSL, right? But generally, most of the load balancers will be HTTPS load balancers, right? Second question is the load balancer external or internal, right? So external load balancers are load balancing traffic coming from the internet, right? Internal load balancers are load balancing traffic but within GCP, right? So again, most commonly, you're going to configure a external load balancer, right? And last question, is the load balancer regional or global, right? So what we mean by that is when the load balancer is load balancing requests across backends, are the backends in a single region or are they in multiple regions? And hence it's a global load balancer. So they're the kind of 3 main questions that I ask when I'm creating a load balancer. Now, generally, when I load balance, my back end is what's called a managed instance group, right? So a managed instance group, you remember we talked about it briefly in Module 1, is a group of identical VMs, right? And also, it's also created from a single instance template. And basically, a managed instance group, or MIG, becomes the back end of a load balancer, right? So what I'm going to do, I'm now going to create an HTTP load balancer with a managed instance group. Just in my case, I'll just use a single managed instance group, but let's just have a look at that, how we do that, right? So again, we'll go into our project, and first thing we're going to do is, well, first thing we would normally do is create an instance template, but I've already got an instance template. But creating an instance template is a lot like creating a virtual machine, except you are creating a template, right? So basically, creating a template doesn't actually create any virtual machines, right? It's just used in the managed instance group. But you can see the console looks a lot like creating a managed, looks a lot like I'm creating an instance, but I'm just creating a template, right? Because this template will be used to create identical VMs as part of the managed instance group, right? Okay, so I've already got the template, and one thing to note about that template is I've also got a startup script which will automatically install Nginx on my VMs, right? Because basically I want all my VMs to be running my web application, right? Okay, so I've got the instance template. Now I can create the instance group. So again, if I go down here, I can create an instance group. And basically to create a managed instance group, typically I create a stateless managed instance group because that stateless is suitable for web serving. And you'll see that the thing that I have to do here is okay, give it a name, but I also have to specify the instance template that'll be used to create members in the group. So there I will specify the template that I had earlier, right? Okay, and I also, then I have to decide how am I going to spread my instances? Are they going to be in a single zone or across multiple zones? I'll just go with single zone here. And then I also have the option of auto scaling. So auto scaling will adjust the number of instances in the group based on workload, right? So when there's a lot of requests, I'll increase the number of instances. When there's not so many requests, I will reduce the number of instances, right? So auto scaling will adjust the number of instances in the group based on the load, right? It's dynamic, right? And I also need to I also have to create an auto scaling policy which will signal when auto scaling should occur, right? So at the moment, I'm basing my auto scaling decision on CPU utilization across the group, right? Now, the other thing that I can set up here. So again, I can create that instance group. And oops, so maybe I forgot the health check, did I? No, sorry, I forgot to specify a region. So that just make it US Central. And I think I can create the health check when I create the load balancer. So now I'm creating the instance group. That'll take a few minutes because that will spin up the virtual machines. So we'll just wait for that to start up. And you'll see that at the moment, I've requested 2 VMs to start with. And again, they're just starting up now. So hopefully they will. Okay, so now they're started. So if I click on the instance group and I can see the 2 instances that are being created. They are the members of the instance group. Now they are VMs with identical configurations, right? Now, again, they also show up, of course, if I go into Compute Engine, they show up there as well, right? So they are 2 identical VMs in my instance group. So effectively what I want to do is I want to now configure a load balancer to load balance incoming requests across these instances in the instance group, right? So I've created the instance template, I've created the instance group. Now I have to create the load balancer and connect it to the instance group. So let's do that. So again, if we go into load balancing, and the other thing also I'll show you here, just before, actually I'll create the load balancer, then I'll show you. So again, we're going to create an HTTP load balancer, right? And again, it's going to be internet facing rather than internal, and it's going to be global, even though we're only using a single region, but we'll just take the default there. And then we'll just call it my load balancer. And again, my front end. And basically I'm going to be load balancing on port 80. So that's all good. And I can click done there. Now, back-end configuration, this is where I connect the load balancer to the managed instance group I created before. So that becomes a back-end service for the load balancer. So I create the back-end service. Let's call it my back-end service. And you'll see here that I can select the instance group that I created before and also put port 80. right? Because again, it's HTTP, right? And the other thing I should configure here is a health check. So a health check is an automatic check on the status of the virtual machines, because I don't want the load balancer to forward requests to unhealthy instances. So this health check is periodically checking on the status of the VMs, and if they're unhealthy, he will inform the load balancer, so the load balancer doesn't send requests, and then I might stop and restart one of the instances or whatever, right? So then I can click on create, and I think I'm good to go then. And then I can create the load balancer. Now, while we're waiting for that load balancer to create, it will take a few minutes. Now, if we go here into Compute Engine, so these are my individual virtual machines. Now, I can check to see whether the web server is configured correctly on each of the virtual machines by connecting to the external IP address, right? So again, if I connect to that external IP address, you'll see that I'm able to connect directly to those virtual machines, right? Similarly, if I try the second one and copy that IP address, public IP address, of course, I can connect to that one as well. And you'll see that the home page is just returning the name of the instance, which is serving the request. But this is, at the moment, I'm connecting to the VMs directly. I'm not going via the load balancer, right? So what I want to do is go via the load balancer. So I have to wait for the load balancer to configure. And again, if we have a look here now, let's just see how he's going. Usually it takes a few minutes to configure the load balancer, because the load balancer has to be assigned an external IP address. So again, if I click on this, you'll see that an external IP address has been assigned to the load balancer, right? So now this is what I want to connect to, because I will connect to the load balancer, and then the load balancer will pass my request to one of the virtual machines in the instance group. So let's just copy that, and you'll see that when we do that, hopefully it's responding now. Okay, so it's still configuring, so we might have to wait a minute or two. Even though the IP address has been allocated, it's still kind of configured. So we might just wait a couple of minutes and come back to do that again. We'll just talk about the load balancers in general. Okay, so basically, when you create a load balancer in Google Cloud, it's a software-defined entity. It's not an actual device. It has its IP address assigned to it, and you've got those different types of load balancers: HTTP, TCP, UDP, SSL, etc. And the most common type of load balancer that you're going to configure is an HTTPS load balancer. So basically, it could be global or regional. It could be internal or external, as we discussed. If it's global, it uses a technique called anycasting to route users to the nearest back end. And basically, it's listening on either 80, 80, or 443, depending on the protocol. Right? URL maps we'll talk about later. Auto scaling is an option I can configure on the managed instance group. Right? Okay, so if I have a global load balancer, you'll see that the global load balancer address might be 120.1.1, as in this example. Now, that address is broadcast around the world, but the magic of anycasting means that if I access that address in California, I will be sent to the instance group that is closest to California, like US West. If it's if I'm accessing that IP address in London, I'll be sent to the back end that's closest to London, in this case, Europe West 2, right? Similarly in India as well, right? So any casting, I mean, this is just by the by, but any casting is an interesting concept because normally we think the idea of one address, one destination, right? But actually with an anycast IP address, where you get sent when you look up the address depends on where you connect to it, right? So anycasting is not unique to Google Cloud. It's a well-established IP technique. Okay, so that's, before we talk about regional spillover, let's go and have a look at our load balancer. It should be configured by now. So if I just hit refresh here, okay, so you see now this is the IP address of the load balancer, right? Now, when I make the request, it also returns the instance name, so the name of the server, so either IPFG or 8KCK. I've got those two instances, right? So if you look carefully on the page here, it's returning the name of the server that is handling the request, right? So if I hit refresh a few times, you should see this change, right? Because sometimes it'll be IPFG, sometimes it will be 8KCK, because that's the nature of a load balancer. So let's make sure the load balancer is doing that. Okay, so that one went to F5G, 5G. Again, see now it's sending it to the other one, 8CK, 5G, 8K, and so on, right? So basically you can see that the request is being sent by the load balancer to different instances to handle that request, because I've got two healthy instances, right? Yeah, so yes, the IP address is allocated to the load balancer, right? Because that is the endpoint that the application is connecting to. So you'll see this is the front end of the load balancer, and that is the same IP address I'm putting in my browser. Okay, so that's okay. So what's the idea of a regional spillover? Well, imagine I've got backends in both California, London, and Mumbai. What happens if the Mumbai server goes down, right? Or backend goes down. So what I would do in that, or what happens if there's too many, it's being overwhelmed with requests? Well, in that scenario, I will temporarily route requests from India to Europe West 2 or the next closest region, whether it's Europe West 2, which is probably a bit close. London's probably a bit closer to Mumbai than California. Right? Okay, so we talked about a back end, and a back end is where the request will be handled. So it'll hit the load balancer and then it'll eventually be forwarded to a back end. We'll talk about URL maps later, right? Now, the most common type of back end is a managed instance group, which is what I showed you just now, right? But I can have other types of back end. So for example, I can have what's called a network endpoint group, which is basically something like App Engine or Cloud Run. I can also have storage buckets as the content servers, because I can serve HTTP directly out of a backend storage bucket as well, right? Okay, so there's a list of the supported backend. So the one I showed you was the instance group, but I can have other types of backends as well. Right. Okay, so you saw how I could set up the back end when I create the load balancer. We saw that before. And we also saw the idea of a health check. So a health check is, as the name implies, just a periodic check on the health of each of the VMs in the group, right? So basically, if it's not healthy, I don't want to send requests to that instance, right? And again, in a managed instance group, not only will I not send requests to it, but I will also remove it and replace it with a healthy instance. Okay, so we saw how we could set up the health check before. And we can either do that at the console, as I showed you, or we can do it with the command line, with the G Cloud Compute Health Check Create. Okay, now we also have the option to set up routing rules or URL maps, right? So this is only for HTTP, right? So the scenario for that is, imagine I have a website and I'm getting two types of requests, right? Requests for video highlights. So imagine it's a sporting site, right? And I'm also getting requests for news items, right? Now, so what I want to do is maybe I want one group of servers, high-end servers, to handle the video requests, right, from the net. But I want a second group of servers, let's just call them low-end servers, to handle news items, right? So in other words, what I want to do is I want to look at the incoming URL and route the request to the appropriate request handler, right? So maybe I want to set up a rule. Any URL with flash video goes to the high-end servers, right? Whereas everything else goes to the low-end servers, right? So in other words, I want to route the incoming request based on the URL, right? So that is what is meant by a routing rule, right? Okay, so I'll just pause there and see if there's any request. Okay, no questions. Good. Okay, so I can basically, looking at the URL, I will determine which backend will handle the traffic, right? And the front end is pretty simple. We just basically say which port we're listening on, and also we'll talk about the network service tier in a later discussion or later today, right? Okay, so I didn't realize that was the next slide, but anyway, let's have a look at it, right? So network service tier is basically it's a property of external IP addresses, right? And what it does, it determines how communication takes place with the IP address from outside the region, right? So if I have premium, communication is mostly on the Google private network, right? But if it's standard, if I have a standard IP address, communication is mostly on the public internet, right? Okay, so let's just quickly demonstrate this. So what we're going to do is we're going to create two instances. What I'll do is I will just delete this load balancer now that we've seen how it operates. Delete that. And what I'm going to do is I'm going to create 2 instances, one with a premium IP address and one with a standard IP address, right? So we'll call this instance P here. And again, when we go down to networking, so when I go to the external IP address, you'll see that the default network service tier is premium. So that's okay for this one. I will just create this one. And I will also create one standard, which has a standard IP address. So in every other respect, the VMs are identical, right? So let's go down to that, and we will change the premium to the standard network service tier, right? Okay, now the standard network service tier is, well, let's have a look at the difference first. So now we've got those 2 instances, and just let me, okay, so now we're going to, what we're going to do is these 2 instances are in US Central, right? So what we're going to do is we are going to go to a German ISP. Just let me find it. Okay, yeah, so basically here, and there's a protocol on the internet called traceroute. So what traceroute is, it shows you the intermediate destinations between your location and your destination host, right? So you can use this to understand the pathways that your packet is going through, right? So here we are on a German ISP, and what we're going to do first is we're going to communicate with the premium IP address, right? So again, I'll just copy that, put that there, and basically put in that code, HDZG, I think it is. Okay, and click go, right? Now, when I do that, so we're on hertzner.com. Now, you can see that almost immediately, the packet disappeared off the public internet into the Google private network, right? So that's why we can't see the intermediate locations, because it's going on the Google private network. So when I'm communicating with a premium IP address from outside the region, I get onto the Google private network as soon as possible, right? Because that's going to be faster, right? But if I just compare this path with the standard one, so here's the standard one here. So we'll copy that one, and we'll change this one here and put in a new code, SFFC, I think it is. Okay, so you can see intuitively that I'm spending more time on the public internet before eventually getting onto the Google private network, right? So with the standard requests, I spent more time on the public internet. So what does that mean? That means my communication will be slower, but it will be a little bit cheaper, right? So the trade-off on network service tier is, what is most important for your communication? Do you want it to be highly performant, or do you want it to be as cheap as possible? So then you would choose the appropriate network service tier. Right? Okay, and that's what they're saying here. So with premium, read this right to left. So there's my destination IP address. I jump on that I get off the public internet as soon as possible to get onto the Google private network, right? But with standard, I spend more time on the public internet, like we saw when we looked at the trace route output. Okay, so again, what's more important, performance or cost? Well, obviously that's going to depend on your application, right? And when I say the cost, it's not a huge difference in cost or a huge difference in performance, but only Google can offer this kind of choice because only Google has that type of private network. Right? Okay. Okay, now the next thing we are going to talk about is how do we protect our load balancer, right? Because if we look at, because our load balancer is a software-defined entity, but it does not sit on a virtual machine. It does not sit on a VPC, right? So let's just have a look at this architecture here. Sorry, it's just a little mud map, so hopefully you can see it. But I've got my two virtual machines in my managed instance group, Web 1 and Web 2, and they are sitting on a VPC, right? And I've got my load balancer in front of them where the request comes in from the internet and the load balancer chooses one of those requests to chooses one of those virtual machines to handle the request, right? But the point is that the load balancer is in GCP, but he is not in a virtual machine, right? Sorry, he is not on a VPC. He's in another area of the Google Cloud Network. So firewall rules only protect things inside a VPC. So how are we going to protect the load balancer? Because he's outside of VPC, right? So the answer to how we're going to protect him is a technology called Cloud Armor, right? So Cloud Armor effectively enables me to attach to a endpoint like a load balancer about which IP addresses are allowed to connect or which ones are not allowed to connect, those type of rules, and create a Cloud Armor policy and attach it to the load balancer endpoint, right? So I have to have something like Cloud Armor because the load balancer is sitting outside of the VPC, and it's only with Cloud Armor that I can protect the load balancer, right? The endpoint, right? And basically what I do in Cloud Armor is I create a series of security rules such as IP allow and deny lists or geo blocks or whatever, create those policies, attach them to the endpoint, right? Now, for the VMs, I can protect them with firewall rules because they are on the VPC, right? But the load balancer is not, so I need a different type of technology to protect the load balancer. And that is provided by Cloud Armor. Okay, and as we said, we use Cloud Armor to create network security policies and then attach them to our load balancer. Right? Okay, so let's say I wanted to block a particular IP address. I